Now we're going to see how muscles get energy and types of muscle fibers. Let's think about what you learned in Chapter 3 about ATP. Remember that ATP stands for adenosine triphosphate. So it's an adenosine with 3 phosphates attached. And that third one is attached by a high energy bond. Hopefully this is coming back to you from our Chapter 3 lessons. When you need energy, you break that bond. After you break it and the cell gets the energy, you are left with ADP, with the D standing for di for 2. And then that phosphate you broke off is by itself. Then the cell regenerates this. So remember, these two things go to the mitochondria and you reattach that phosphate. And you're back to having ATP. So the basics of getting ATP is you just attach a phosphate to an ADP. Muscles have multiple ways to do this. In Chapter 3, you learned about aerobic cellular respiration, where you do glycolysis, then the pyruvates enter the mitochondria, you do Krebs and electron transport, and you attach the P to the ADP. You also learned about fermentation, when you go into oxygen debt and the mitochondria shuts down and you just do glycolysis. So you already know 2 methods. In muscles, there's 4 methods. So we're going to take those 2 you already know, and we're going to add some more. This picture of the track is showing you when you use each of those 4 methods. We're going to start with the pink one. So notice the pink is the first part of the track here. Here's your start line. The pink is the one you use when your muscles first start working. And this is the phosphagen system. So phosphagen is the immediate energy when a muscle first starts working. Notice, though, how short-lived it is. It's only those first few strides of running around the track. So it's immediate, but it is short-lived. Next, we go to this orange one. So you can see here, here's runner number 2. He's continuing on around the track like this. The orange one is anaerobic. Aerobic means oxygen, and when you put a or an in front of the word, it means without. So anaerobic, you're not using oxygen. Okay, this is what you switch over to after phosphagen. So you can see even runner number 2, he started in phosphagen, then as he kept running, he switched to anaerobic. Number 3 is yellow. So I'm going to use kind of this tan color instead. Here's runner number 3. And see, he started here in phosphagen. Then he went to anaerobic. Then as he comes around about to this part of the track, he switches over to the yellow. This is the one you already know. This is aerobic cellular respiration. This is the one where you use oxygen and you get lots of ATP. This one produces the most ATP. Then the fourth one, it's not shown on the track here, but eventually you would go into fermentation. This is when you would have oxygen debt and you're forced to go into fermentation. You can't do aerobic anymore because your oxygen is not there to supply it. So that's an overview of the 4 steps. So you go through these 4 in order. So now we're going to look in more detail at each. So here is the phosphagen system. This is also sometimes referred to as phosphate transfer. Okay, the first part of this, it has 3 components. The first part, ATP already present in muscles. So when you first start using a muscle, when it goes from resting to being used, you're going to use ATP that's already there. The second part is where you use an enzyme called myosin kinase. So this is an enzyme. Okay, enzymes are going to build or break molecules. They're building and breaking bonds. Here's what you start with. You have 2 ADPs. So that's an adenosine with 2 phosphates. And we have another one. The myosin kinase enzyme comes along and you end up with an ATP, which is what we want, and then AMP. In this case, the M stands for mono, which means 1. So hopefully this is pretty simple to figure out. All this enzyme did was take a phosphate from one ADP and give it to the other. So you started out with 2 adenosines, each with 2 phosphates. You take one away, give it to the other. Now you have an adenosine with 3 and you have an adenosine with 1. Our third one is ADP. So we're going to have an adenosine with 2 phosphates, then creatine phosphate. Then this enzyme, creatine kinase, comes along, and then you have an ATP and just creatine by itself. Same idea. The enzyme took a phosphate from here and gave it to the ADP. This last part here is showing resting muscle. So this is what you do when you're not using the muscle. It regenerates its creatine phosphate. So when a muscle's resting, it will use ATP. It will take a P off of the ATP and give it to the creatine. So then you get a DP and creatine phosphate. Then when your muscle's working again, you're ready to go with this. You may have heard of creatine as a supplement. If you look at like the muscle milk that bodybuilders use, it is a supplement to help with building muscle. Okay, there's nothing special about creatine phosphate that makes muscles grow, but what it does do is give more energy for lifting weights. So the idea is it enhances your workout because you have more energy and you can lift more weights. I think of that South Park episode where Cartman took the weight gain 9,000 because he thought he would get big muscles, but all he did was sit on the couch and eat cheesy poofs after his weight gained 9,000 and he just got fat. He didn't get big muscles. So there's nothing magical about it that'll make your muscles big. You have to do the workout lifting the weights, and it just gives you more energy to do that. All right, then the next one is anaerobic. This is where you just do glycolysis. So you can see you take glucose either from the blood or you get glucose from glycogen stored in the muscle. If you remember back to chapter 2, that chapter 2 post-class assignment, when you have extra glucose, your muscles will store it as glycogen. So you can also get glucose from glycogen in the muscle. Glycogen is just stored glucose. Then you're going to break the glucose into 2 pyruvates. And you get your 2 ATP. So this is a pretty fast way of getting ATP. This is good for quick bursts of energy. Think of this like a firecracker. Anaerobic is great for things like sprinting and weightlifting. Things where you just need quick bursts of energy. Then we move on to aerobic. This is what you learned all about in chapter 3. This is where you do glycolysis. And you get your pyruvates. Then the pyruvates enter the mitochondria, where you do Krebs and electron transport. Okay, so here you can see you can get glucose from the blood, you can get glucose from glycogen. But you have other options. You also can get fatty acids and amino acids and send those into your mitochondria. So you have more options for your fuel source. And aerobic, the name literally means oxygen. So you also need oxygen going to the mitochondria. So as you can see here, you can take oxygen from the blood, or you can use your stores. So just like glycogen is stored glucose, you have myoglobin that stores oxygen in your muscles. So you can also get oxygen from the myoglobin in your muscles. So if we define myoglobin, it is a molecule in muscle that stores oxygen. So aerobic is going to give you lots of ATP. This is your big ATP producer. And how long you can keep doing aerobic varies from person to person. And if you remember back to chapter 3, it varies based on how much oxygen you have. which goes back to the health and efficiency of your heart and lungs. So you can keep doing aerobic until you go into oxygen debt. And this, how long this is, depends on your heart and lungs. So a well-trained athlete has really good heart and lungs that can do this for hours. Somebody who's out of shape is only going to be able to supply oxygen for maybe a few minutes, and then they're going to be done. Then our last one is fermentation. So everybody eventually will go into oxygen debt if you keep exercising. So fermentation is once your heart and lungs can't keep up with your muscles. So there's no more oxygen going to the mitochondria. So if there's no more oxygen, you shut the mitochondria down. Remember the moose out front? Says, sorry folks, park's closed. So there's the moose. The moose tells the pyruvates they can't come into the mitochondria. So now, because the mitochondria is shut down, you can only do glycolysis. And you're also starting to get lactic acid. You convert your pyruvates to lactic acid. And you only get 2 ATP, which is not very many. So once you go into fermentation, your muscles start to shut down. You're going to stop exercising. So those are the 4 ways that muscles can get energy. Then we can look at types of muscle fibers. So there's 3 types here. I'm just going to focus on the 2 ends, the 2 extremes, because the ones in the middle are just kind of medium on everything. So we're going to look at slow oxidative and fast glycolytic. So first we'll talk about slow oxidative. If you break the name down, slow, they're slow to get going on their ATP production. These are not the quick burst of energy. These take a little bit of a lag time. And oxidative means they use lots of oxygen. Another name for these fibers is slow twitch. If you're into sports, you've probably heard discussions of slow twitch and fast twitch fibers. These fibers specialize in aerobic. So most of their ATP comes from aerobic cellular respiration. So think about the features, the physical features they would need in order to specialize in aerobic respiration. Aerobic uses oxygen. So that means they're going to have lots of myoglobin because they use lots of oxygen. And myoglobin is red. So these fibers have a red color. And since they use a lot of oxygen, They also have lots of mitochondria. So these fibers are using lots of oxygen, lots of mitochondria, and making lots of ATP. So they are fatigue resistant. This means they don't get tired easily. They can keep working for a long time. So this chart shows some other features. I'm not going to talk about everything in the chart. I went over a few highlights, and you can look at this chart for the rest of the features of slow oxidative. Now let's look at fast glycolytic. They are fast because they are fast to respond. And glycolytic means that they use glycolysis. So these fibers specialize in method number 2, the anaerobic. So they're using lots of glucose. So this means that they need a lot of glycogen. And since they're only doing glycolysis, that doesn't use oxygen. So they have a very low oxygen use. So since they don't need very much oxygen, they lack myoglobin. So this gives them a white color because of the lack of myoglobin. And you can see up here, these lighter colored ones would be the fast glycolytic. Also, since they're not using oxygen, they don't have much use for mitochondria because mitochondria is the part that uses oxygen. So they are low in mitochondria. These fibers have quick burst of energy. So they are quick and powerful, but they fatigue quickly. When it comes to the fibers, there's 2 things to take into account for how many you have. So the first thing is the function of the muscle. If we look back at the chart, we can see that slow oxidative tend to be found in trunk and lower limb muscles. Remember, these are the fibers that are fatigue resistant. They can work for a long time. So your trunk and your legs are what have to work for long periods of time. Your trunk is where your posture is, and you have to stay upright all day long. And your legs carry you around all the time. You stand, you walk. So they tend to have lots of slow oxidative. Here you can see for fast glycolytic, upper limb muscles. So your arms are mostly fast glycolytic. Your arms tend to work in quick bursts. You pick things up. but you don't walk around on your arms. You don't sit there all day holding things up above your head. So your arms work in quick bursts. And a lot of times when you're picking things up, it's heavy and you need a quick, powerful burst. So arms have a lot of fast glycolytic. So the function of the muscle is one factor in determining which type of fiber you have more of in that muscle. Genetics is another factor. So everyone has both types of fibers. But some people are born with more of one than the other. This is where natural talent comes from. If we go up to these pictures at the top, you can see here is our distance runner. This person has a natural talent for running marathons, and this person has lots of slow oxidative. So that's a genetic trait. He was born with a lot of slow oxidative fibers, so he's better at endurance activities. Here's our sprinter. If you look at the sprinter's muscle, you see lots of fast glycolytic. This gives him a natural tendency towards sprinting. So training, of course, is part of it, but the number of each type of fiber you have can give you a natural tendency toward one type of activity or the other. So there are your fiber types.